Hello everybody and welcome back to another episode of Practical PyTorch. Today I will be covering a little bit of Kaggle fun. I've been working on the Airbus ship detection challenge for just a minute now, and I thought I'd show you guys where I am and what I'm up to. Hopefully my keyboard won't be too loud. I listened to my last stream and the keyboard was pretty loud, so I may need to do something about that. But without further ado, let's get right to it. So I've got a Jupyter notebook set up here, just ships.ipython notebook, and I'll walk you through what I've done so far. Those here. So you've got your standard imports, and what I have here is let's go cd data ships. So we have a sample submission, which I'm not interested in, some zip files I need to delete. But then what's interesting here is this CSV and then this train v2. So if I ls, train v2 to head, this is just a few images. It's actually quite a big folder. It really makes the server chug. And then if you cat this file, and this is now these encoder IDs, image IDs, with run length encoding. So basically what this represents is, maybe I'll pull this up on Kaggle website later. Let's just zoom in a bit for you guys. So these images, hang on, there we go, got it. Alright, so let's do this again. Okay, so this is the image, and then these are the pixels that are hot in that image. So you start at the 246,661th pixel, and then 17 of them are hot. And then you go to 265,429th, and the 33 of them are hot. So if that doesn't make a lot of sense, that's okay. I'll now show you what I'm up to here. So let's just do this. Okay, so that's borderline readable. Mouse is a little bit jerky. I'll stick to the keyboard. So what I'm doing here is I'm bringing in the segmentation data, and then I'm opening the file, creating a segmentation CSV, and then for row in the reader, I append it to this rows list. And if length is greater than 10, I just break because I don't really care right now. I just want to get a feeling for the data set. I'm just building the data loader, and then you can see here this is the row, and it looks just the same as how we were just printing it out onto terminal. Right, and so then I've got my images, and so the image path is root, and then I just grabbed this image right here. I guess I could have done this a little bit cleaner, but that's how it goes when you're prototyping. And so let's just run all of these actually to make sure I'm current. Okay, so image path, image. I open the image using pill, and then I print it out right here. So we can see this is just a satellite image of some land, some sea, and then some stuff right here that looks kind of like ships, which is kind of exciting. So if I scroll down a little bit more, you get the size of the image. And now I'm going to create my mask. This is where it gets interesting. So notice it's 768 by 768, so I'm just creating NumPy zeros of that exact same size. And you could probably also, so notice this is NumPy zeros of just this. This is not a two-dimensional array at this point. So if I go here and just mask.shape, this is just a one-dimensional array. So if I do mask at the first four items or whatever, this is just a long array of zeros. And the reason I'm using a 1D array and not a 2D array when it's the mask, so obviously it needs to be the same size as this, is because this run length encoding is not given with dimensionality, right? So this is 361,252. This is a pixel that is as if the image was basically unraveled. So you have to start, or no, you don't have to, right? But this is what I've found. You start with just a long array, and then let's just delete this. All right, and you start with a long array, and then you add in these pixels, and then you reshape it to be the size of the array you want. And so I'll show you how I'm doing that. So this is just a little bit of nonsense here that I found on Stack Overflow, because what I need to do is I need to iterate through this list right here, but I need to iterate it through in batches. So I need to get this bit right here, and then I need to get this bit right here, and this bit right here. And so what this is doing is it just creates an iterator and yields the two next items. So hopefully that's not too confusing. Basically, it just creates, you pass in an iterable, or it could be an iterator as well, basically just a list of items, which this is, and then it creates an iterator out of it, and then it just walks through that iterator, yielding the next 2 items every time it gets called. And so that effectively ends up with this system right here. So I can do, just for your information, print pixel runlen, right? And I'll just comment out this. Let's just print this out. Okay, pair was not defined. There we go. So now we've got each item inside of this this row. And so you can see this is kind of interesting. It goes 1, 3, 4, 5, 6, 7, 8, 9, 10, 10, 14, 15, and then slowly back down. So you can kind of see, so I'll kind of skip to the spoilers here, but if you, what I'm doing here is, I'll take this. So I'm taking the mask at pixel, right? And then up to mask at pixel plus the run length equals 1. So I'm setting it, it was 0, and then I'm setting it to be 1. So for this, it's just like one little pixel blur. But over here, that's setting like 10 pixels to be 1, which is creating the mask. And so if we look down here, this is what that ends up looking like. So once you reshape it to be 768 by 768, you can in fact look at the data, and it looks like this. So there's obviously a ship on this corner. But if you scroll up to the original image, which this should correspond to, there's obviously no ship up here, right? This is wrong. So there's something going on here. I imagine it's just a flip or transpose away because of the way that images work. This is the 0th coordinate. The top left is 0, 0. But when I do a reshape of a one-dimensional array, there's no guarantee that that's where 0, 0 is, right? So there's something going on there, and I'm gonna play with that now. So let's see what I can do here. Mask.shape. All right, so okay, now there's nothing there because I forgot to run this. Okay, there, now it's back. And let's just make sure that I'm on the right track. So 0021dc3.jpg corresponds to this, corresponds to 0021dc3.jpg. Cool, so it's the same image. And I'll need to clean up this data loader in a second once I get a proof of concept. But for now, what I'll do is I'll just say, mask image equals mask dot, same thing, reshape 768, and let's just see what are the arguments to reshape. So shape order equals C. That's interesting. What's the order? Unlike the free function, this method allows the elements of the shape parameter to pass in separate arguments. For example, a.reshape. Oh, cool. So I don't even need this extra tuple. Refer to numpy.reshape for the full documentation. Okay, you're gonna make me work for it. That's fine. np.reshape. What are the... Okay. C. Read the elements using this index order and place the elements in the reshaped array using this index order. C means to write the elements in C-like index order, with the last index changing fastest, move back to the first index changing slowest. F is Fortran. A. Okay, so this is, I don't think this is what I'm looking for. Basically what I'm looking for is a way to reshape, but to get the image the way I want it, but I don't think that's going to happen. So instead what we're going to do is this, plt dot mask image. Oh, come on. Oh, I haven't run that. I guess that's why not. Why autocompletion isn't working. And now let's look around to find out how I can flip and transpose this. So numpy transpose, or let's just do flip 2D array. Let's start with that because maybe I should find a more obvious example. Yeah, let's do that. Let's see if I can find an example where the ship is a little bit more obvious. So print row. Okay, so let's try this. Print rows at, say, actually let's do this. So index equals 5 or 4. I guess we're doing 4. Print rows at index. There we go. So now we can do this instead. Rows at index at 0. This should be the file name. So we'll just do that for this. I'm just trying to set up a slightly systematic way to do this. Wait, hang on. Come back, please. No. I broke it. Rows at index at 0. Image path. Image. Okay, so that was a little bit more promising. We've obviously got, I assume that's a ship. This is some stuff here. So we've got the image. And then we'll do, you know, image size, and then rows at index. So we'll say, you know, row equals row at index, and the rest of this code will work. Index out of range. Oh, I'm sorry. Yes, it is. There we go. So now if we run this again, boom, there we go. So now we've got wow, it's only one ship. Really? Okay. That definitely looks like more than one ship, but maybe these are not ships. Maybe this is the ship. But let me just zoom out a little bit. Sorry, guys. I know you might not be able to see it as well. So this is the ship. It's kind of, so it's facing like this, facing the top left corner, and it's kind of right center of the image. And then over here, the image, it's basically just flipped, right? So the ship needs to be over here. So I think it's just mirrored up across both dimensions. So let's see what we can do. What will NumPy let me do today? Okay, rotate array clockwise, flip array in the up-down direction. Rows are preserved but appear in a different order than before. Okay, that sounds pretty promising. So what if I just MP flip up down the array? So let's see, 1 0 0 goes to 1 0. Okay, so that is what I want. I don't know if this will handle the dimensions I'm using well, but we'll see. Right, so then we'll say, you know, flipped mask equals. Whoop, okay, I just copied that line. Let's go back here, NumPy, flip up down. And there we go, NumPy flip up down. What? Okay, I can't copy paste, is not working. Not that I need it in this instance. And then we'll do NumPy, what was it? We're just gonna shot in the dark, flip LR. Flip LR, mask image. Right, so there we go. Now if we do, you know, flipped mask, boom, there we go. So now if we scroll up, looks pretty promising. And to be sure, we should probably overlay them. So let's do this. Im is that. Right, so now we can do plt.imshow mp array of im. Boom, there we go. We have the two of them. And now let's overlay them. Array plus flipped mask flipped mask dot max. What are these? 1.0, whereas im, I bet you, is 255. Oh sorry, 220. Yeah, so this is a different scale, so I need to do flip mask times 255. Could be not broadcast together. Oh yeah, fine. How do we do this? This is always so annoying. Alright, probably the easiest way is just to clone this with MPD stack. So we'll just say, you know, 3 channel, you know, 3 mask equals mp.d stack flipped mask, and then what do you just do this 3 times, I think? Invalid syntax. Yep, that is invalid syntax. Alright. Alright, and then 3 channel mask dot shape. That looks like it'll be a little bit happier. And then 3 channel mask times 255, because again, this is not big enough. And now we go boom. So there we go. This is thoroughly messed this up. Not really what I wanted. 3 channel mask times 255. Nope, still messing it up. That's weird. Let's see here. Let's see. Overlaid equals. Let's grab this. And overlaid dot max obviously is going to be super high, min, and that's what I thought. So now let's do np.clip, and with the values in an array, overlaid, so clips overlaid equals np clip overlaid, and then min should be 0, max should be 255, and then we can just do clipped overlaid here. Nope, still not working, but you do see this is obviously very black. Why is that not working? This should work just fine. Overlaid. This is really annoying. plt.imshow 3 channel mask. Yeah, that's what I think it should be. So it's all zeros and with a couple ones, right? I mean, that's, and then if you add that to be 255, the rest of the image shouldn't get messed up. I don't know why that's happening, but I think the mask is on point, so I'm not going to worry too much about it. And I think I should probably move on to setting up a little bit more of a systematic data loader. And I'm going to kind of chalk this up to imshow being really annoying. I don't know, I could bring in like CV2 and add weighted or something like that. That might actually not be that hard. Maybe it's worth doing. Let's try that really quickly while I'm here. Import CV2. There we go. So now overlaid CV2. Variable names get pretty ridiculous when you're just raw prototyping. CV2.add weighted, and let's see, source 1 is going to be overlay. Wait, hang on. This what is this? Oh, hang on. That's, yeah, it's not defined. Overlaid plus 3 channel mask and 55. This should work. Okay, yeah, that wasn't the problem I thought it might have been. But really what I need is, 3 channel mask, comma 0.5, and then what is this? MP array im should be the next one. I'm going to get all sorts of data type errors here. 0.5, and then the output should be destination. Oh, maybe destination is not. Oh yeah, you just return destination. That's fine. And then gamma should be 0. Yep, bad argument. The output must be explicitly defined. Let's just make sure the shapes are the same, just to be sure. Whenever you do this, you want to make sure the shapes are the same and the data types are the same. So shapes are good. Now let's do data types, because I guarantee the data types aren't the same. Alright, so we got floats and units, which is not what you want at all. 3 channel mask. That's another thing is, wait, 3 channel mask dot max is still not what I want, right? So 3 channel, let's do this. I don't like doing this, but we'll just do 3 channel mask equals 3 channel mask times 255. Now it's in the right ballpark, but it's still the wrong data type. Really what we want is 3 channel mask as type mp.int32. CV2 likes int32. And then this as type CV2, np.int32. And let's just go back here and do that. So now it's pretty readable. Overlaid CV2 works just fine. Overlaid CV2. What's going on? 3-dimensional arrays must be of type. Oh yeah, sorry, I forgot about this. So the relationship between CV2 and matplotlib is just a real mess. So anytime you go between the two, it requires a whole lot of explicit D-type stuff, which thankfully is easy, but I'm not going to say it's not annoying. Okay, there we go. So it's still turning all this red, which I'm confused about. But you can see the mask is clearly on point. So I think we're in a position where we can kind of go ahead and write a data loader here and get started actually training a model, which took 20 minutes. So that's not so bad. There's enough code here that I can piece together a data loader. So let's put this aside for now and see code. ls cd. Okay, so we're gonna do Mugder Kaggle streaming. Yeah, I'll just call it Kaggle. I don't know if that's a bad idea. Move Kaggle stream comp cd Kaggle comp. All right, so ls touch ships dl.py touch main.py touch ships net.py. All right, cool. So let's start with the ships. Ships data loader. So what do we need here? CV2 I'm not going to be using, map.lib not going to be using, CSV I will be using, so it's these three, and this one as well, and let's see, class ship data set. How do we want to set this up? I'm going to need training, and I can't think of anything else for now, so we'll just stick with that. So I try to avoid, need a new tmx window. Let's get some nice hard-coded paths here, so I don't mess in, no relative paths. Data, ships, pwd, this right here is my path, so let's see, self.path equals, oh sorry, yeah, we'll just do this, path. Cool, got that. So then we'll have self dot mask data equals. So what I'm just doing here is I'm just setting up all the initial files that'll be needed. This is always kind of annoying, but it just needs to get done. Alright, so self mask data fname, and then now we'll grab in this, which is needed, and wait, hang on, let me just turn off paste, set paste. That would be annoying. Oh, looks like it's still annoying. Great, I can't wait to fix this. 5k, with open, let's do this. Self.rows. And yeah, this'll work just fine. And then yeah, self.this. Okay, so this is just going to walk through with open. So this is wrong. So I don't need the mask data fname. I'll just rename that mask data fname. There's no need to self that. You know what I mean? Fname. It's not going to be needed. There we go. Oh, what's going on here? Alright. So now we're getting in our CSV, we're getting all the rows, rows.append, and then image, so now let's get image file names, right? So I guess let's do self, what is going on here? Oh, sorry. Set no paste. Self.image fnames equals this right here. So root train v2 rows index at 0. And it's self.path, not root. Train v2 rows index, and it's not rows, it's just the current row. Alright, so that'll get, then now we have our image fnames. Oh, sorry, append, right? So let's say this is a list. Dot append. Alright, let's do this now. This probably isn't terribly entertaining to watch, but hopefully you guys get an idea of how to set up a data loader quickly and efficiently. And then this, I think, will probably all go in the get item. So let's do this. Def len self return len of self.rows and def get item self index And this is all fairly standard stuff straight out of the PyTorch data loader tutorials, hopefully with a little bit of extra pizzazz. So what's going to need to happen here is first, we'll open the file name. So we'll say RGB equals this, and we'll say self.image file names at index. And once we have the RGB open, we just need to create the mask, and so we'll just do let's see, I want to dynamically create the mask based on the image size, just in case I end up resizing the image, just as good practice. So let's do this. Mask equals mp.zeros, and the shape should be rgb.size at 0 times rgb at size at 1. There's cleaner ways to do that, so maybe I'll clean that up in a minute. And then there's this pairwise iteration nonsense, which I'll bring in. I'll just leave that as a helper function outside the class. Sorry, let me just redo that. Nope, not what I wanted. Alright, set paste, there we go. Set no paste. I love having to do this every time. I love how Vim can't figure that out. Okay, so let's go up here a bit and figure out what we want to do. 4-pixel run length in pairwise row -1. So this needs to change. So it needs to be self.rows. Hey, what's going on? Self.rows at index at -1.split mask. Alright, so that will work. And then do this. Oh yeah, first reshape it, right? So then we just do this. Alright, so then we flip it, and then we're pretty much good. Then there's a bunch of 3-channel nonsense that I did for visualization, but I really don't care about that. This is looking pretty good. So now I'll return. So I'm gonna leave. Oh yeah, so I guess I should. Let's think here. I need to think about this. So the flipped mask is a numpy array, so we can just return that. We'll just call it ground truth, flipped mask. But then we need to return, normalized RGB, and we'll normalized RGB, and there we go. So that'll work. That's all we need. Now all we need to do is create this normalized RGB thing, and we'll do it like this. Hang on, I can't remember how to do this. PyTorch pre-trained models. I'll show you guys what I'm up to in a second here. Basically what I'm looking for is the RGB is a pill image, right? So this is pill, it hasn't been changed. And I need to transform it to be a numpy array that has been normalized so the data is nice, because right now it's 0 to 255. Neural networks don't like that. We should normalize to 0 to 1 or -1 to 1 or something like that. And a good way to normalize is this right here. So this will allow us to normalize in such a way that it'll work for all ImageNet trained models like these, which is convenient because I'll probably end up using a pre-trained model like this. So let me just go up here, say we go like this, and bring this in a bit. Okay, so we'll just leave normalized down there, and I should probably, what else do I want to add? This is normalization, and then first, so what's important to realize is that normalize expects a certain thing, and so let's just look into PyTorch transform normalize. So I kind of know the answer here, but I'll just show you guys this hit quickly. It'll help you understand how normalize works. So normalize a tensor image with mean and standard deviation. Given mean and standard deviation, the tensor will normalize each channel input, right? So this expects a tensor image of size channel height width, which is not what I have, right? So what I have is a pill image. Where is it? Right here, right? So let's go back here, and if we look down here, there's this thing called toTensor, which converts a pill image or NumPy array to tensor. Converts a pill image height width channel to a float tensor of shape channel width height of the range 0 to 1. Channel width height, so we scroll up back to this, it expects channel width height. So toTensor is designed to be used in conjunction with a lot of this stuff, including normalize. And so now I'll show you guys Compose if you haven't seen it. Compose is very nice. It allows you to do stuff like this. So let's do this right here. Now I'll write my transforms. Self.transforms equals transforms.compose, is it? Yep, it is. And the first one is going to be transforms to tensor, which is what I need. And the second one is going to be normalize. And that'll be it. And now I can go down here, 14 down, sorry, wrong way. And now I can say normalized RGB equals self.transforms of RGB. And that'll work just fine. Now we've got a data loader set up that's gonna work. We just need to import the right things. From Torch Vision, import transforms. Let's see if this works just off the top of my head. Transforms. I have no idea if that'll work. Okay, so now let's go off somewhere else. Let's go back to Kaggle comp ls, and I guess the way to do this would be to go to main and from ships.dl import get.dl, and you might say, hey, you haven't written that yet, and you'd be right. So let's go back to DL actually, and go here, def get.dl, and we'll just do some training bool, and then we'll do batch size int, and let's see, PyTorch data loader. How do I import this? Torch utils data, that looks promising. From torch.utils.data import data loader. Am I right about this? Oh, I never even clicked it. Let's see here. So what I'm looking to do is I have a data set which exposes len and get item as it should, and now I need to create a data loader to deal with that data set. And thankfully, PyTorch has a very nice data loader which takes in a data set object, batch size, shuffler, etc., etc., etc. All very convenient things. And so what I'll do here is I'll just say, let's go down here, and maybe just add in this, so I can add things to the data loader as I need them. So first we'll say data set equals, ship data set, training equals training, right? So now I've got my data set object, and now I've got I'll just return data loader, and what am I going to do? Data set, what else? Batch size equals batch size, and shuffle, and then I'll just add in quargs. So this way, if I want to, I can, change the keyword arguments and all sorts of stuff, right? Sampler, all this stuff I don't really care about right now, but I might later, so I'm just designing this to be useful. Alright, so let's go to the the main file, that's what I'm calling it today. Main file from ships import get ship.dl, and then we'll say, dl equals get dl, and what does it expect? Training equals, so we'll say this is the train data loader, get dl true, and let's start with 8 as a batch size, see how that goes for me. And then we'll just say for data in train dl, import pdb does set trace, right? So let's just check out what this is even going to do, because I'm sure I've got all sorts of problems. So python main.py, Alright, inconsistent use of tabs in indentation. Oh, very nice. Let's go back to my ship's data loader. And let's do this. Vim convert to spaces. How do we do it? I know it's super easy. Somebody show it to me. Retab, that sounds promising. Set tab stop. Ingesting intent. Oh, come on. How do I do it? How do I do it? Oh, yeah, it is just retab. I was thinking too hard. There we go. Let's go ahead and close this notebook. I'm getting tired of it. Let's go back here. Thank you, notebook. You served your purpose. Close you. Close you. Alright, so next. Okay, did I even write the file? Let me know file. Okay, so normalizer DB 48. What's going on here? Oh, sorry. There we go. Let's try this now. That looks promising. It's thinking, it's thinking. None type not callable. Interesting. Get DL, init, self F names. Ship dataset has no attribute image F names. Oopsies. It looks like I did something wrong. Line 21. Oh yeah, I just kind of I didn't actually do anything here. Equals that. There we go. So now that's a list. Okay, let's run this again. IO operation on closed file. For row in segmentation CSV. Oh yeah, just kidding. Doing that totally wrong. V3 V. How do I do this? V. Okay, so segmentation CSV for row. Nope. There we go. And then self.tree. Yeah, this should work better. What are we at? 37 minutes here. Okay, so I'll be done in a minute. I mean, that's a lie. I won't be done in a minute. I won't lie to you guys. Whoa, what's going on here? Image ID. Oh, yeah. Okay, so this is so stupid. The first row of this CSV, where is it? Get item. Yeah, so this actually got into get item now. So if we go back to this cd data ships ls cat, this file right here, head. Actually, let's do this. I'm tired of this. Mector.old. This is probably what I should have done a long time ago. Zip old ls. Cool. So now when I do, you know, cat train ship, it doesn't suck so much. So see, the first array is a. I'm sorry. The first item is this stupid header. So really, what we need to do is, after we're done with creating these rows, we immediately delete the first one. So let's just go 3 down, del row at 0, right? Which is not the best, but it's also gonna work just fine, and there's no reason to over-engineer this. It's just a small data loader for a Kaggle competition, and I want to move quickly here. No such file directory. Okay, so still failing. Del row, yep, because there's what I did makes no sense. Self rows 0. Let's try that. Yep, thank you, bye-bye. So basically, I'm appending all the rows, and I just delete the first one, because that's the one with the headers. Okay, don't even write it this time. Let's try that again. Okay, none type not callable, that's something I can work with. No such file, no, it's not something I can work with, it's still happening. Get item. Okay, so we need to actually do some debugging here. Import pdb.setTrace. Let's actually take a look at what's going on. Alright, so p index is 0, and then if we p self image file names at index, yep, sorry. It's this. Okay, so it is in fact this thing. Oh, because I deleted the row, but I never deleted the f names. Is that why? Yep, that would be why. Silly Daniel, didn't think of that. Del self.image f names at 0. This is getting dumber and dumber. So now if we p index, p self.image, f names, add index, keep doing that, that's great. Okay, so now it's a real file, I assume. Let's try, I guess I could have just continued from there, that would have been smarter. Let's wait for this to rerun, continue, oh yeah, this is great. Cool, some of the strides on a given numpy array are negative, this is currently not supported, will be added for future releases. That's interesting. What does that mean? Torch.stack, torch from numpy b for being, how the strides are negative. Let's go down a bit here. Import pb. It's like the collate function is failing, and what does this mean? Okay, I don't actually know what this means, so we're gonna have to figure this out together. What are they talking about? Error in tensor. This should not give an error. How am I doing here? How about torch x is 0, copy. The stride, what does it mean for stride to be negative? I understand what stride means for, oh, interesting, okay, yeah, so because I flipped it, it's now messed up. Interesting, so because I flipped it, it's now messed up in memory, torch can't deal with it, and so now it's time to do a copy. So let's see if this will work. So I'm flipping the mask. Let's go 3 down. Flip mask dot copy. So maybe we'll get lucky and that'll work. Invalid syntax. Yes, it is. Sorry, I'm naughty. Sorry, I won't ever say that again in reference to me being unable to code. For data in train data loader. Hey, look at that, we made it out. So we're now in train.py, or sorry, main.py. So now we can p len of data, p, data. So now let's do this. This is my favorite thing to do. I mean, not my favorite, but that's an issue. String has no attribute shape. For O in data. Oh, haha. Okay. Let's try this again. I forgot it was a dictionary. P item dot shape for key item in data dot items. I think this is how you do it. There we go. Bingo. Bingo, baby. Okay, cool. So now we have this mask, 8 by 768 by 768. 8 by 3 by 768 by 768. Okay, so this is now, we now have the data loader working. It only took 43 minutes, and my dinner is going to burn in the oven, so if I don't turn this off soon, but let's see if we can just get a basic thing running, right? So let's go back here, for data and train data loader. First I need a model, right? So model, ships net, yep, ships net, import torch, from torch import n, torch vision, import model zoo, is it? Torch, I have this open already, it's right here. From torch vision.models as models, that's what I wanted. Come on, let me edit the file. Nope, fuck off, thank you. So now we can say, let's just grab Resonant 18 really quickly, and pre-trained, yeah, obviously. Hey, sorry about that, just sneezing in the microphone here, so we'll just say, yeah, we'll just leave it at that right now. Obviously, we're going to need to do a lot of changes in the future, but let's just stick with that. Actually, no, let's wrap this. Class ship model def init self. Sorry, this needs to inherit, right? So we got to get an module self. That's pretty much it. And so we'll say self.encoder equals this right here. Okay, so what I'm doing here is I'm just setting up an encoder, which I'll modify shortly, and then I'll do def forward self x. So I'm just going to use encoder as an initial starting point, and then I'll do so I'll say x equals self dot encoder x. I'll just pass it through the resnet, and then I'll do x equals f dot interpolate x, and then we'll say, I think I just do 768. We'll see how that goes, and return x, right? So I'm just going to pass it through the encoder, and then I'm going to resize it back up to 768 by 768, and we'll just see how that goes. So this is just a very kind of naive first pass to get the net working. Let's go up and say, you know, model equals, what is it called? The ship model or something like that. Thank you. And then for data, RGB equals data at RG. No, it's like normalized or whatever. I don't know what I called it. Yeah, that sounds about right. And then preds equals model dot ship model. Let's do this. Make sure everything's on CUDA. Ship model dot CUDA. And model.CUDA, model RGB.CUDA, and then we need loss. Let's go with cross entropy loss. Wait, hang on. We're gonna need to figure something out here. This isn't totally done, but it's getting close. And then I'll do, you know, I need an optimizer and a loss function, right? So loss equals cross entropy loss, optim equals atom, and then I think I need to do like model dot parameters, if I remember correctly. And so now I'll do for down loss equals pareds, and then data at ground truth, and then optim.step or something like that. A PyTorch training loop. Let's see how this looks. I think I've Googled this before, which is embarrassing. I really should just save it or something like that. So optim.step. Yeah, there we go. You get the outputs. I guess we got a 0 grad. Optim.0 grad. Optim.0 grad. Okay, cool. And now let's do some work here. From torch.optim import atom. From tqdm import tqdm. And where do you get cross entropy from? NN. Oh, it's just NN. That's nice. From torch import NN. Sorry, dot NN import. There we go. Okay, getting a little excited there. So I think that'll. Oh wait, right. The issue is the ship model doesn't actually work. This is not at all what I want. I need another layer. This is binary segmentation. You are predicting either a 1 or a 0, right? And so what is the output of ResNet? Anybody know? No? Okay, well let's just do this and take a look at what we can see. All right, so let's run this. And we'll build this net together, because this is what needs to happen. Ship model is not defined. Whatever. Why do I need to import everything? Why can't you just know what I want? From ship, what is it? Yeah. Shipnet. Shipsnet. Import ship model. Alright, there we go. Hopefully you guys can hear me okay. Nobody's complained yet. Alright, bada bing bada boom. Ah, yes, that's another issue. So it just downloaded the pre-trained model, but what's unfortunate is that I forgot this. or sorry, is it super.init or self.init or super.init. So super.init. There we go. Let's run this again. So this just so everybody knows what I'm doing. You have to inherit from NN module, and in order to get all the goodness from NN module, you have to do this. This is just a Python idiosyncrasy. You have to initialize the superclass promptly after initializing your class. So basically, every single neural net in PyTorch is going to look exactly like this. You get the class, some name of your own design. This will always be the same. This will always be the same, and this will always be the same. And then they'll set up their encoder or whatever their model is doing, and then they'll have a forward pass. So this is all very, very similar. Size mismatch, 8 by whatever, 500 by whatever. What are you whining about? Okay, so it doesn't like... Oh, because ResNet... what is going on? Self-fully connected layer. F.linear. What is going on? I put a PDB here. So it's okay, so it's breaking inside of ResNet, which is strange considering this should be able to go through ResNet without issue. I guess not. We'll try this. Let's go here. 51 minutes. My potatoes are going to burn fairly soon, so I will need to hop off. Oh, pretty soon actually. But first, let's just see if we can do this. So px.shape, 8 by 3 by 7. Is that what PyTorch wants? That's my potato timer, so I'm going to hop off in just a second. PyTorch transforms. I don't care about normalize. That should be what it wants, right? So if I just continue, no, it'll still give me this error. Let's just check this out really quick, and then I think I'm going to hop off, pick this up probably some other evening. I do have some other stuff I wanted to get done tonight, but I am making good progress. I have the data loader handled. Theoretically, the initial net should be handled. What are we doing here? 8 by 3 by 768 by 768. To tensor. Where is the... Yeah, that's what it should be. 3 by 768 by 768. I don't know why that's failing. It should be able to handle this, but it's not, obviously. So I'll have to, let's try a different ResNet, right? I've never really used ResNet 18, so maybe there's something broken about that it's expecting something else. Let's go with ResNet 50. Let's try this. ResNet 50 is going to give back 1,000, like it's 1 by 1,000 or whatever, because it's an image net, which is annoying, so I'm going to have to sabotage that somehow or something, I don't know. Okay, let's go next. Nope, size mismatch, 8 by this, M2 is 2048 by 1,000. Okay, yeah, so there's something's going wrong here inside of the encoder. I'm gonna have to do some investigation, but that'll have to wait for another night. Anyway, thanks for tuning in, guys. Hope this was an interesting insight into kind of how to get started on a Kaggle competition. I promise there will be more interesting stuff coming down the pipeline. And yeah, feel free to comment, like. Don't bother subscribing. I'm not good enough for that. But let me know, let me know what you think. All right, have a good night, guys.